So in this video, we're going to take everything that we've learned so far and put it all together to work on writing linear systems, modeling real-life situations, and figuring out how to solve them. So when you're solving these systems, you can choose whatever you prefer and make sense given the context of the problem. You can solve the systems by graphing, substitution, or by linear combination. So when we work on these word problems, you want to be on the lookout for these words and phrases that represent math symbols. It's going to be a whole lot easier to translate the word problems into these equations if you can identify any of these phrases and words. So remember our strategies for solving word problems. We're always going to start off by trying to understand the problem. So it's very important to underline, circle, or outline the important information and define any variables. Then we're going to make a plan. We're going to set up the equations that are within the system, and then we're going to solve these equations, remembering to show all our work and check our solutions. Then we're going to reflect on the entire process. You want to verify that your solutions make sense in the context of the problem. Because remember, we are talking about real-life situations, so we want to have values for our variables that will make sense. So when we solve the systems, you can use each of the different methods. You can use graphing when both of your equations are already in y equals mx plus b form. Substitution is a good method to use when one equation is already solved for a variable. So if you already have an x equals equation or a y equals equation, it's a good idea to use substitution. Linear combination can be used to solve any type of system, so if graphing and substitution don't work, you can go ahead and use linear combination. So you may remember this problem that was from the very first lesson in this unit. So now we're going to work on solving it. So you and a friend go to El Super Taco after school. You order 3 soft tacos and 2 burritos and pay $11. Your friend pays $8 for 4 soft tacos and 1 burrito. Write and solve a system of equations that can be used to determine the price of a taco T and the price of a burrito B. So let's highlight the important information here. So we have 3 tacos and 2 burritos for $11, $8 for 4 tacos and 1 burrito, and we're thinking about the price of a taco T and the price of a burrito B. So let's define our variables. So we have T, which is the taco price, and we have B, which is the burrito price. So now that we've identified our variables, let's set up our system of equations. So we have 3 tacos, so I would say 3T, and is usually a plus sign, so and 2 burritos for $11. Then we have 4 tacos and 1 burrito for $8. So these are the 2 equations that form our system. So now we want to think about how to solve them. We can't use graphing because they're not both in y equals mx plus b form. Substitution isn't really a good idea because we don't have our equations already solved for one variable. So let's go ahead and try to use elimination. So whenever we're using elimination, which is another way of saying linear combination, is we're going to try to figure out which variable we want to get rid of. So if I think about this, if I had my ideal situation, maybe I'd have something like a 2b and a minus 2b, right? So I want to think about how I can multiply one of my equations in order to get that minus 2b. Well, if I take this second equation and I multiply everything by negative 2, I can maybe get that minus 2b, right? I can actually multiply every single term in this equation by negative 2. So my new equation would become negative 2 times 4t, which is negative 8t, and then negative 2 times 1b, which would be minus 2b, and then negative 2 times 8, which is negative 16. So now I can combine this with that top equation, that 3t plus 2b equals 11, and I can put these 2 equations together. So when I do that, I get 3t minus 8t, which is negative 5t, plus 2b and minus 2b will cancel, and then I have that equals 11 minus 16, which is negative 5. So now to solve for t, I can go ahead and divide both sides by negative 5. So when I do that, on the left, I get t equals negative 5 divided by negative 5, which is 1. So now I've done half of the work in this problem, right? I figured out the price of a taco. I now need to figure out the price of a burrito. So I can use one of these equations to do that. So I'm just going to use that 3t plus 2b equals 11, and I'm going to plug in this value that I have, this t equals 1. So when I plug that in, I get 3 times 1 plus 2b equals 11. So 3 times 1 is 3 plus 2b equals 11. So 3, remember that is a positive 3. So to move that 3 away from b, I'm going to do the opposite and subtract 3 from both sides. So when I do that, on the left, I am left with 2b equals 11 minus 3, which is 8. So I have 2b equals 8. So now I need to work on solving this equation for b. So I'm going to divide both sides by 2. And when I do that on the left side, I'm left with b. And then on the right, I have 8 divided by 2, which is 4. So that means that a taco is going to be $1, which is what I solved previously. And a burrito is going to be $4. And these are both reasonable solutions given the context of the problem. If I want, I can plug them back into the equation and verify that it's true, right? If I plug into this first equation, I get 3 times 1 plus 2 times 4 equals 11, and that is telling me that 3 plus 8 equals 11, which is true. I can also plug into the second equation, 4t plus 1b equals 8. I get 4 times 1 plus 1 times 4 equals 8, and that is telling me that 4 plus 4 equals 8, which is also true. So that's how you can check your solutions. So now let's try this problem. A bus travels 2 different routes, the green route and the blue route. The routes are different lengths. On Monday, the bus traveled the green route 6 times and the blue route 5 times, traveling a total of 52 miles. On Tuesday, the bus traveled the green route 12 times and the blue route 13 times, traveling a total of 119 miles. What is the length of the green route in miles? So let's now find the important information. So we have the green route and the blue route. On Monday, they went the green route 6 times and blue route 5 times, total of 52. On Tuesday, they went green route 12 times and blue route 13 with a total of 119. And we want to know the length of the green route. So notice that in this problem, it's not actually asking us to solve for both variables, right? If we define our variables, which we don't have letters for our variables defined already, so we can just make them up. I'll say that g is the length of the green route, right? Because that is what it's asking us for. And then the other route that we have that is unknown, we have b, which is the length of the blue route. So now let's work on setting up our system of equations. So my first equation is going to come from Monday. So on Monday, they go green route 6 times, so that's 6g. And is usually a plus. We have blue route 5 times, so that's 5b. And then we have a total. Total is one of those words that represents the equal sign, so we have a total of 52. Then we have Tuesday. So on Tuesday, we have green route 12 times, so that's 12g, plus blue route 13 times, so that's 13b, and that equals a total, once again, of 119. So now I'm going to work on solving this system. Graphing is not a good idea because it's not in y equals mx plus b form. I can't use substitution because I don't have one of my variables solved for. So I'm going to use elimination. But when I use elimination in this problem, I'm going to kind of be smart about it, okay? Because notice that this problem doesn't ask me for both variables. It just says, what's the length of the green route? So I only technically need to do half this problem. I only need to find the value of g. So if I eliminate and get rid of the variable that's not g, right? If I get rid of the variable b, I can actually do this problem with half the amount of work. So what I want to do is I want to figure out how do I get rid of b. So let's look at that. Coefficients of b are 5 and 13. So I need to figure out the LCM of 5 and 13. So the LCM of 5 and 13 is 65. So what I need to do is I need to turn one of these b's into a plus 65b, and I want to turn the other one into a minus 65b. Well, I need to now figure out how I go about doing that. So the first equation, I can take that first one and I can multiply everything by 13, right? So if I multiply every single term by 13, let's see what will happen to that first equation. So I'm going to distribute 13. And when I do that, I get 13 times 6 as my coefficient of g. So 13 times 6 will give me 78. So I have 78g plus 13 times 5, which is 65. So I have 65b. And that equals 52 times 13, which is 676. So now I want to turn the b term in the second equation into a negative 65, right? I want this to be a negative 65. So to do that, I'm going to have to multiply that entire equation by -5. So I'm going to do -5 times 12g plus 13b equals 119. So once again, I'm going to distribute. -5 times 12g is -60g. -5 times 13b is going to give me that -65b. And that equals, now I have to do -5 times 119. So -5 times 119 will give me -595. So now what I'm going to do is I'm going to combine these two equations together. So when I do that, I have 78g minus 60g. That will combine to give me 18g. 65 and minus 65 will now cancel, and then I have 676 minus 595. So 676 minus 595 is 81. So I'm going to continue this problem over here. I have 18g equals 81. Now I need to divide both sides by 18 to figure out the value of g. So when I do that, this will cancel. So I have g equals 81 divided by 18, which gives me 4.5. So 4.5 miles is the length of the green route, which is all I need to do to solve this problem. It's not asking me for the length of the blue route, so I don't need to plug back in and find the value of b. So in this problem, it says that the Frosty ice cream shop sells sundaes for $2 and banana splits for $3. On a summer day, the shop sold 8 more sundaes than banana splits and made $156. How many sundaes S and how many banana splits B did they sell? So let's find the important information. So we have sundaes for $2, banana splits for $3. We have one day we sold 8 more sundaes than banana splits and made $156. So how many sundaes and how many banana splits did they sell? So we know our variables. We know S is the number of sundaes and B is the number of banana splits. So let's figure out what equations we need. So we have sundaes for $2 each. So we have 2 times the number of sundaes and banana splits for $3 each. So 3B. So that's how much money we made, right? So 2S would tell us the total from sundaes. So this is talking about money. And then 3B would tell us the total money from banana splits. So the money total, right? So the total amount of money that we made is 156. Right? So that's why that would be my first equation. So then what it tells us is that the shop sold 8 more sundaes than banana splits. Okay, so the number of sundaes, right, is going to be 8 more than. So more is going to be plus, right? So if you remember, 8 more than is going to be 8 plus B. Okay, so S equals 8 plus B. So this is going to be our system of equations now, right? We have 2S plus 3B equals 156, and we have S equals 8 plus B. So let's look at this system and now figure out what would be the best method to solve. So it's not really good to use graphing, right? Because we don't have y equals mx plus b form, but we can use substitution, right? Because one of our equations is already solved for a variable. So I can take this 8 plus b and plug it in for s into this equation, which is exactly what I'm going to do. So I'm going to do that, and I get 2 times 8 plus b plus 3b equals 156. So what I can do now is I can distribute this 2. So if I distribute the 2, I get 2 times 8, which is 16, plus 2 times b, which is 2b, plus 3b equals 156. So I have 16 plus 2b plus 3b, which is 5b, and that equals 156. So now this is a positive 16, so I'm going to subtract it from both sides to work on solving for b. So I have 5b equals 156 minus 16, which is 140. So when I have 5b equals 140, I now divide both sides by 5 to solve for b. So when I do 140 divided by 5, I'm going to do that on my calculator. And I get 28. So I have b equals 28, and that is the number of banana splits. So now to figure out the number of sundaes, I can use either of these two equations. I'm just going to use this s equals 8 plus b because that's already solved for sundaes. So I have s equals 8 plus b. So I have s equals 8 plus 28, which equals a total of 36 sundaes. So that means that the Frosty ice cream shop sold 36 sundaes and 28 banana splits on the day that they described in the word problem. And these two numbers do make sense, right? It is a reasonable number of banana splits and sundaes for an ice cream shop to sell. So in this problem, it says the length of a rectangle is equal to triple its width. Use the system of equations to find the dimensions of the rectangle if its perimeter is 26 centimeters. So let's highlight the important information. So it says the length of a rectangle is equal to triple its width. So we're finding the dimensions of the rectangle and the perimeter is 96. So on these kind of problems with geometry issues, I like to draw out a sketch. Okay, so I'm going to sketch a rectangle just so it gives me an idea. So when we're talking about a rectangle, we know that this is the length and this is the width. So it tells me that the length equals triple its width. So I'm going to define my variables. L is the length and W is the width. So I just write my L in cursive like that so that you all can tell the difference between that and the number 1. So let's write this first equation. It says length is, remember is means equals, triple, remember means 3 times, and then we have width. So let's translate that first sentence into a math equation. So we have L equals 3W, right? Length equals 3 times width. And then it tells us that the perimeter is 96. So let's think about what is the perimeter of a rectangle. How do we describe perimeter? So perimeter, remember, is when you add up all the sides. Well, remember that a rectangle has 2 sets of congruent sides. So like if this side is L, that means that this side is also going to be L. They have the same size. If this side is going to be W, this is also going to be W. So if we add up all the sides, we have L plus W plus W. So if I combine those together, I have L plus L, so that's 2L, plus W, that's 2W. So this is basically telling me that 2L plus 2W equals 96. So that is now my second equation, 2L plus 2W equals 96. So now let's think about how we're going to solve this system of equations. We don't want to use graphing because it's not in y equals mx plus b form, but we can use substitution because this equation is already solved for L. So I'm going to substitute 3W into this equation where I have L. So I have 2 times 3W plus 2W equals 96. Well, 2 times 3W is 6W, so I have 6W plus 2W equals 96. 6W plus 2W will combine to give me 8W equals 96. Now to solve for W, I'm going to divide both sides by 8. So that gives me W equals 96 divided by 8, which gives me 12. Okay, so 12 is the width. Now we need to figure out the value of the length. So I'm just going to use this equation, this L equals 3W. So I have L equals 3W, and I'm going to plug in W equals 12. So I have L equals 3 times 12. So that is L equals 3 times 12, which is 36. So that means that my width is 12 centimeters, because that is the units I had in my problem, and the length is 36 centimeters. Okay, so those are the 2 dimensions of the rectangle in the problem. So in summary, remember when we apply systems, you want to read the question carefully and look for any key terms and phrases. Then you're going to write each equation individually, and we're going to determine the best method to solve the system, graphing, substitution, or linear combination, and then we'll use the appropriate method to solve for the values of the variables.